video is the second of a 6-part series that aims to provide an overview of wastewater operations at meat processing plants and guidance on their day-to-day management. In this video, we will explore in more detail the first set of treatment processes. As they are upstream of other treatment processes, they are commonly described as primary treatment. Meat processing wastewater can be difficult to treat properly compared to other industrial wastewaters due to its high concentration of contaminants such as suspended solids, oils and grease. Typically, the raw wastewater has high concentrations of suspended solids, particularly in green streams. These suspended solids arise from operations such as emptying of paunch and manure or grit from stockyards. If not removed during upstream treatment, these solids settle out in downstream ponds and fill them rapidly. The wastewater is usually rich in oil and grease, which hampers downstream treatment processes and produces floating scums and crusts in downstream pits, basins and ponds. It is common to measure temperatures as high as 50 to 60 degrees Celsius in red waste streams from meat plants, especially where rendering is part of the facility. This is too hot for downstream biological processes in the treatment plant. The preferred temperatures less than 35 degrees Celsius. High temperatures also emulsify oils and greases into the wastewater, preventing removal by primary treatments. These three characteristics complicate downstream biological treatment and are the main reasons for the failure in downstream biological treatment processes. The primary treatment processes used in the meat processing industry typically seek to do one of three things: reduce suspended solid concentrations, reduce oil and grease concentrations, or dampen variations in flow. Let's now explore primary treatment processes as they apply to a meat processing plant. Technologies used for reducing suspended solids levels include static screens, which are vertical bow-shaped screens that have no moving parts. They're usually made of a wedge wire screen to reduce blockages by fine solids or fats. A more recent innovation is a baleen screen, where the screen is a fine flat screen which slopes slightly. A mechanical water spray arm pushes the solids away from the filter for disposal. Rotary screens have a rotating horizontal cylinder. The wastewater enters either inside the cylinder or on the outside top of the screen. The solids are moved to the opposite end to be discharged. Both static and rotary screen can be binded by fats and are susceptible to overflowing. A screw press is a rotating screw in a barrel. At the inlet end, wastewater passes through a screen for initial dewatering. At the other end, compressed solids form a plug, against which the incoming solids are compressed for even further dewatering. This device is highly effective at dewatering fibrous solids such as manure and paunch. The discharged solids can be quite dry to touch. This generally reduces solid waste disposal costs, particularly those based on weight. Hydrocyclones are used for separating dense solids such as sands and grit from water. Wastewater is pumped into the conical end, creating a swirl, causing denser particles to be flung to the inner wall and slide down to the bottom discharge for dewatering and disposal. Finer solids remain in the majority of the wastewater stream, which is discharged near the top. Technologies used for reducing oils and grease include a save-all, which is simply a large settling tank in which the raw wastewater enters, generally after pre-screening. Sufficient time, usually 30 minutes, allows fats to separate and float to the top, and for heavier solids to sink to the tank base. Surface scrapers gently tease the floating fat off the liquid surface for discharge in skip or to a screw press for reprocessing. Some save-alls are also fitted with base scrapers to remove solids in a similar manner. A dissolved air flotation, or DAF, is a common sight in Australian meat plants. DAFs inject a high-pressure stream of liquid containing high levels of dissolved air into the raw wastewater stream. The dissolved air forms a mass of very fine air bubbles. These bubbles attach to particles and fat globules and lift them to the surface, where they form a float of aerated material. The floating material is scraped off for disposal or reprocessing, and the cleaner water underneath is discharged. The dosed dissolve air flotation process is exactly the same, except chemical coagulants and polymer are mixed into the wastewater feed, increasing the removal of oil and grease and suspended solids. De-oiling hydrocyclones are similar to degritting hydrocyclones, where the less dense oil and grease phase exits at the top of the unit and heavier water flows out the base. These hydrocyclones are very effective at screening non-render red streams. A major challenge for most meat plants is the wide variation in wastewater flow during a 24-hour day. Typically, the largest flow occurs during the processing shifts when water consumption is at its maximum, especially when cleaning. For most meat plants with downstream anaerobic ponds, there is little need for balancing the wastewater flow, as the anaerobic pond acts as a very large balancing pond. In these cases, a save-all or wastewater pump pit is the only form of flow balancing. Where wastewater is discharged to sewer via a chemically dosed DAF, more care is needed to provide a more consistent flow, so a large balancing tank is often used. The main challenges for balancing tanks are minimising odours, ensuring they are mixed to minimise solid settling, and minimising corrosion. If there are any regulatory requirements relating to primary treatment, these will be stated in your plant's Environmental Protection Licence, permit or approval issued by the state government. There are, however, significant health and safety concerns with upstream processes, mainly related to the risk of confined spaces such as pits and save-alls. Raw wastewater which remains stagnant for long periods may generate potentially toxic levels of hydrogen sulfide. Extreme caution must be exercised in entering such places. Any such activity should comply with confined space regulations. Upstream treatment systems usually require the bulk of a wastewater operator's time. Operators need to spend a considerable amount of time cleaning plant to minimise blockages, prevent overflow and minimise presence of vermin. Incidents can be common and overflows can bring about significant environmental damage, public nuisance such as vermin, offensive odour, increased cleaning requirements and even fines from state authorities. Discharges are typically wet, sloppy, fatty and unpleasant to handle and may be significant in volume, up to 100 wet tonnes a week or more for a large plant. Solids should be handled carefully, since spills often return the material to the wastewater treatment system and/or sewer, which is undesirable. Inspections are usually undertaken several times a day to ensure everything is operating properly. In particular, operators need to watch out for overflows, blockages, especially of inlet pipes and screens, or equipment failures such as pumps.
Blockage is easy to find out because you can see that it's nothing coming, you know it's blocked. The pump, you only see that. But the system I'm operating is good because they got alarms to let you know that's close to overflow.
Operators should also check that monitoring equipment, such as flow meters, are functioning properly. If breakdowns or malfunctions do occur, maintenance should be notified. Operators of upstream wastewater treatment plants also need to continuously monitor for changes in the wastewater stream.
The operation is not the standard that you set one in the morning and it will work all through the day. During the day, you can't change on how you operate the wastewater, because you never know what the waste coming through the production, so you just have to monitor. If in the event of the blood coming through or the tallow coming through, you immediately inform the supervisor or the production manager. Tallow is easy and blood is easy to identify because they change the color of the water. The sticky water is very hard to see. The next morning you'll pick it up on the data readings and then inform the production manager straight away.
In the case of DAFs and save-alls, operators should also check scrapers are operating correctly, that it is not too fast or too slow. Weekly inspections should also include a check on the build-up of solids on the bottom of tanks if bottom scrapers are not installed. The degree to which upstream processes need wastewater quality monitoring depends on the unique features of the plant. Twice a year, operators should collect a sample of the wastewater exiting the upstream process for analysis in an external laboratory. Such measurements need to be undertaken by people with experience in sampling high variable wastewater streams. Where chemical dosing of the DAF plant occurs, quality monitoring is more important and regular, especially if the DAF-treated wastewater is discharged to sewer. This sampling and testing will typically occur daily at least. The operator may conduct some testing on site to help control the process. The proper operation of upstream processes is essential to the robust and reliable performance of the entire wastewater treatment plant.
Wastewater treatment systems can be likened to dominoes. If the upstream treatment process begins to malfunction, downstream treatment processes will generally fail, and this can be expensive to fix. The main responsibilities of management are to ensure that appropriate investment and maintenance support is provided to the upstream treatment area. Supervisors should monitor the upstream treatment area for evidence of large amounts of blood or tallow. This may indicate that valuable product has been lost down the drain. They should also oversee the proper disposal of waste solids from the upstream process area. Regular monitoring of discharge to sewer also needs to be conducted to meet discharge conditions and assess the operation of the treatment plant.